When you're deploying surveillance in remote Africa, whether it's a mining camp, a national border, or an isolated village, you face two brutal realities. First, there's no power grid. Second, there's no fiber. Trenching fiber optic cables in sub-Saharan Africa can cost tens of thousands of dollars per mile. That's before you even think about cameras. Traditional solutions try to solve this by stitching together components from 5 different vendors: a controller here, a 4G modem there, a battery bank somewhere else. The result is a fragile house of cards. One failed router, one true cable, and your entire system goes dark. And the near-saint technician is 3 hours away. AirLink takes a completely different approach. We engineered the 4G module directly onto the camera's main board. No external modem. No extra cables. No additional failure points. The camera boots up, establishes a secure WireGuard VPN tunnel automatically, and registers to the AirLink Cloud. Zero manual configuration required on site. We call it plug and forget. Now let's talk about power. The SD6-27 solar kit includes a 60-watt panel and a 300-watt lithium-ion battery. Why lithium-ion? Because traditional lead acid batteries permanently degrade if you discharge them past 50%. In the field, that means your system dies faster than expected. Lithium-ion supports nearly 100% depth of discharge, no chemical damage, no capacity loss. Even during heavy rainy seasons with multiple days of cloud cover, the system keeps running, and the hardware itself, engineered to survive equatorial heat up to 60 degrees Celsius. No silicon failure under the African sun. What happens when the 4G signal drops? Most systems restart the VPN connection from scratch. That takes time, and during unstable cellular conditions, it means constant dropouts. AirLink uses WireGuard VPN, a stateless protocol. When the signal drops, the tunnel simply pauses. The moment the signal returns, it resumes instantly. Meanwhile, the camera keeps recording to a 64 to max 512 GB SD card. When connectivity is restored, the system performs a prioritized sync, sending AI event metadata and snapshots first so the operator can immediately see what happened. Full resolution video stays local and is only pulled over the network when specifically requested. This dramatically reduces cellular data costs. The imaging core uses Sony STARVIS Sensors, IMS 415 and IMS 335 with backside illuminated architecture. By repositioning the wiring matrix behind the photodiodes, the sensor captures significantly more light. The result: full color imaging in near total darkness, without activating power-hungry infrared LEDs. This is critical for solar deployments. Every milliwatt saved on IR LEDs extends your battery autonomy. The system also uses single-frame HDR processing exposure row by row in one pass. No ghosting on fast-moving vehicles. No blurred license plates at checkpoints. For government and military contracts, AirLink offers source code licensing, allowing integrators to build a fully self-hosted closed-loop environment on the client's own servers. Absolute data sovereignty. And because we use Japanese-made Sony Sensors, the system is fully NDAA compliant, immune to US-China trade restrictions with guaranteed parts availability and firmware support for the full 5 to 10-year project life cycle. One final point on scalability. Deploy 1 unit today. Deploy 500 units next year across a national border. The architecture is identical. Each camera self-configures self-connects and self-registers. Linear scaling with zero additional complexity. This is not just a camera. This is autonomous infrastructure for the extreme edge. AirLink Alive, plug and forget.